You know that feeling, right? Where time just seems to bend. A really boring lecture can feel like it lasts forever, but then an amazing vacation is over in what feels like a blink of an eye. Well, that's not just in your head. It's a real, profound mystery, and it's rooted deep inside the very architecture of our brains. So today, we're going to dive deep into the neuropsychology of time, this incredibly elastic perception that we all share.
So, what is going on here? Why is our experience of time so fluid? The answer, it turns out, is that our perception of time isn't a constant, like a clock ticking steadily on the wall. Nope. It is a complex and deeply subjective experience, constructed entirely within our minds. Objective physical time might march forward at a steady pace, but our internal, subjective time, well, that's a whole different animal.
All right, let's map out our journey. We're going to start by unpacking why time is essentially an illusion built by the brain. From there, we'll look at the internal clocks scientists think we use to measure it. Then we'll get into how brain chemistry and intense emotions can literally warp our perception. We'll also touch on the strange effects of body temperature and aging. And finally, we'll talk about a powerful way you might be able to reclaim a sense of a longer, fuller life.
So first things first, we have to get our heads around a really fundamental concept. Unlike our other senses, sight, hearing, touch, we don't have a specific organ for time. There's no part of your body that has time receptor cells. It's a sense that our brain has to create completely from scratch.
So if we don't directly sense time, how on earth do we experience it? Well, our brain essentially builds our sense of time. It weaves it together from all these different threads of information. Think of it as an emergent property, like a symphony that arises from three key players: our attention, our memory, and the constantly changing cocktail of chemicals swirling in our brains. Okay, so if the brain is building this sense of time, what are the blueprints? How does it actually do it? Well, scientists have come up with several models to try and explain this temporal processing. Let's take a look at two of the most important ideas.
On one hand, we have the classic internal clock model. It's a really useful metaphor involving a pacemaker and an accumulator. Simple. On the other hand, we have a more modern, more realistic model. It's got a mouthful of a name, the striatal beat frequency model, but the important thing is that it's based on actual brain parts, like oscillating neurons and detectors in a region called the striatum. Let's start with the simple one first, just to get our bearings.
So this older model is, well, it's beautifully simple. Imagine there's a little pacemaker in your brain, just constantly sending out a steady stream of pulses. Tick, tick, tick. Now, when you pay attention to something, a sort of switch flips on, and a device, an accumulator, starts collecting those ticks. The more ticks it manages to collect, the longer you perceive that event to have lasted. But if your attention wanders, that switch flips off, you miss some pulses, and suddenly time feels shorter. Makes sense, right? But as our understanding of the brain has gotten more sophisticated, so have our models. The SBF model, the newer one, gets rid of those metaphorical parts and replaces them with real, observable brain structures and processes. The two stars of this show are the frontal cortex and the striatum.
So here's how this one works. It's a bit like listening to a complex orchestra. You've got all these neurons in your frontal cortex vibrating or oscillating at different rhythms, like different instruments all playing their own tune. The striatum acts as the conductor's ear. At the start of an event, it takes a snapshot of that unique pattern of oscillations. Then, it just listens until that exact same complex pattern repeats itself. When it hears that perfect alignment, it registers a beat, and that's what marks out an interval of time. It's a much more dynamic and, frankly, more biologically accurate picture.
Now this is where things get really interesting, because we're about to add brain chemistry into the mix. You see, the speed of this internal timing system isn't fixed at all. It can be dramatically changed by neurotransmitters, and the main player when it comes to time processing is dopamine. Dopamine is basically the master regulator of our internal clock. When you have more dopamine activity, let's say from drugs like cocaine, which boosts its effects, your internal clock speeds way up. On the flip side, drugs that block dopamine, like some neuroleptics, cause the internal clock to slow way down. And we're not talking about a small adjustment here. This fundamentally changes the rate at which our brain samples reality. So here's the crucial and kind of paradoxical takeaway. When something causes arousal and speeds up your internal clock, it's like a stopwatch that's ticking twice as fast as normal. So in the space of 1 real second passing on the wall clock, your brain has actually counted 2 seconds worth of internal ticks. This is why when your internal clock runs faster, you perceive the outside world as moving more slowly, and you judge events as having been longer than they actually were. And there is nowhere that this link between arousal and time is more obvious than in our experience of really strong emotions. I mean, think about a near miss in a car accident or a jump scare in a movie. Those moments seem to unfold in slow motion, and that's not just a trope they use in films. It's a real neurological phenomenon.
And of course, researchers have tested this in the lab. They showed people different types of films and then measured their time perception. And as this key finding from one study shows, after watching frightening films, the participants consistently judged time intervals as being longer than they did before. The fear was literally stretching their perception of time.
This data breaks it down perfectly. The frightening films, which cranked up arousal, made time feel longer. But what's really interesting is that the sad films, which can actually decrease arousal, had no significant effect at all. And that tells us something incredibly important.
It leads us right to this critical insight. It's not the negativity of the emotion that warps time. It's the sheer level of physiological arousal that comes with it. Fear triggers a massive arousal response. Your fight-or-flight system kicks into overdrive, flooding your system with adrenaline and dopamine. That is what speeds up the internal clock, giving you more mental processing time and creating that incredible slow-motion effect.
Now, beyond these intense, fleeting moments, there are other, more constant factors at play, subtly changing how we perceive time across our entire lives. And two of the biggest are our own body temperature and, of course, the simple process of getting older.
There is a long-standing theory in this field called the chemical clock hypothesis. The logic is pretty straightforward. Since all of our brain's processes are based on chemical reactions, and the speed of chemical reactions is heavily influenced by temperature, it follows that our internal clock should speed up when we're warmer and slow down when we're cooler. And for the most part, studies have confirmed this. When your body temperature goes up, so does the speed of your subjective time.
And that brings us to maybe the most universal and puzzling question about time that we all ask ourselves. Why do the long, endless summers of childhood give way to decades that just seem to fly by in the blink of an eye? Well, science actually has several really compelling theories.
Okay, so there isn't just one answer here. It's likely a combination of a few really powerful ideas. First up, you've got the novelty theory. Think about it. Your childhood is just packed with firsts. Every day is a new adventure, creating these thick, distinct memories. But adulthood, it can get pretty routine, right? Fewer memory markers mean that when you look back, the years just kind of blur together. Then there's the simple, almost brutal math of proportionality. When you're 5, a single year is a massive 20% of your entire life. But when you're 50, it's just 2%. It feels smaller because, well, it is a smaller piece of your total experience. From a pure biology standpoint, we have the dopamine decline theory. As we age, levels of this crucial neurotransmitter naturally go down. This might actually slow down our brain's internal sampling rate, making the world outside feel like it's speeding past. And finally, let's talk about attention drift. As adults, we spend a lot of time thinking about the future or dwelling on the past. We're just not always present. And if you're not paying close attention to the now, your brain doesn't bother encoding the details, and time just slips by.
You know, understanding all these mechanisms isn't just some academic exercise. It actually gives us a clue, maybe even a key, to consciously influencing our own experience of time. If a lack of new memories makes time feel compressed and fast, then maybe, just maybe, the solution is to actively create more of them.
This is the core of what's called the novelty effect, and there's a deep evolutionary reason for this. Our brains are wired for survival, so when we encounter something new or unusual, our attention systems kick into high alert to figure out if it's a threat or an opportunity. Key memory-forming areas of the brain, like the hippocampus, become super active. This rich encoding process doesn't just help us learn, it also makes time feel much more expansive when we look back.
And really, this is the profound takeaway from all of this. While we can't magically add more hours to our day or years to our lifespan, we can influence the perceived length of that life. A life that's rich with new experiences, new challenges, and new learning creates a much denser, richer tapestry of memories, and that's what makes our time on this earth feel longer, fuller, and more meaningful.
So I'll leave you with this question. And this isn't about planning some grand round-the-world adventure. It's about breaking your routine in small ways. Maybe it's just taking a different route home from work, trying a new food you've never had, or starting a conversation with a stranger. What new, distinct memory will you consciously choose to create today to stretch the fabric of your time and make your life feel just a little bit longer?